We build houses for many reasons. We need shelter from the rain and wind, we need a safe place for our families, and we need buildings for our communities. But safety is the most important thing. Every year, fires and earthquakes happen. These events can damage buildings and hurt people. We must build structures that can withstand these dangers. Fireproofing means making a building resistant to fire. This does not mean the building cannot catch fire. It means the fire will spread slowly. This gives people time to escape and firefighters time to arrive. There are many ways to fireproof a building. We can use special materials that don't burn easily. We can design the building to stop the fire from spreading. We can also install fire safety systems like sprinklers and alarms. Some materials burn easily, like wooden fabrics. Others resist fire better, like concrete and steel. Concrete is very strong and does not burn. Steel is strong but can melt in extreme heat. We can treat materials to make them more fire resistant. For example, we can coat wood with fire retardant paint. This paint helps to slow down the spread of fire. We can also use fire resistant insulation in walls and ceilings. The way we design a building can also help to prevent fires. We can create fire compartments to contain the fire. These are like separate rooms with fire-resistant walls and doors. We can also install fire suppression systems. Sprinklers are a common example. They spray water when they detect heat, putting out the fire quickly. Fire alarms also alert people to danger, giving them time to escape. Section 5. Earthquakes, preparing for the Earth's tremors. Earthquakes are sudden, violent shaking of the ground. They can cause buildings to collapse, which is very dangerous. We cannot stop earthquakes, but we can make buildings stronger. Earthquake-resistant buildings are designed to sway with the movement. They absorb the energy of the earthquake and stay standing. This involves special techniques for the foundation, structure, and materials. Section 6. Foundations, anchoring buildings against the shaking earth. The foundation is the base of a building, connecting it to the ground. A strong foundation is crucial for earthquake resistance. One technique is to use base isolation. Base isolation uses flexible pads or bearings under the building. These pads allow the building to move slightly during an earthquake. This reduces the amount of shaking transferred to the structure above. Section 7. Structure, building flexibility into buildings. The structure of a building also determines its earthquake resistance. Buildings with flexible frames perform better during earthquakes. Steel is a good material for this because it can bend without breaking. Reinforced concrete, which combines concrete with steel bars, is also strong. These materials allow the building to move with the earthquake's forces. This flexibility helps to prevent the building from collapsing. Section 8. Real-world examples, structures that withstood the test. Many modern buildings demonstrate these principles successfully. For example, the Taipei 101 in Taiwan is a skyscraper known for its earthquake resistance. It uses a massive pendulum to counteract swaying caused by wind and earthquakes. Another example is the Transamerica Pyramid in San Francisco. Its unique shape and strong steel frame make it highly resistant to earthquakes. These buildings show that we can create safe structures even in earthquake-prone areas. Section 9. A safer future. The importance of building strong. Building safety is crucial for protecting lives and property. By using fireproofing and earthquake-resistant techniques, we can create resilient structures. These buildings provide security and peace of mind for the people who live and work in them. As we continue to build for the future, we must prioritize safety. By incorporating these techniques, we can create a safer world for everyone. Let's build strong, build safe, and build for a better tomorrow.